Okay. Hey, everybody. Thanks for coming. I'm actually hoarse because I've been pestering many of you in the audience, telling you about this talk in advance, trying to get your thoughts. My name is Joshua Campbell. I'm here representing the U.S. Department of State, where I serve as the senior advisor to Lee Schwartz, who's the geographer of the State Department. This talk I'm pretty excited about. We've been working on expanding the reach and utility of our boundaries data and how we can make it more available. And what we had to do, what we had to do in order to enable all of that required the development of something called SpaceTime IDs, which I'll get into in a minute. But when I was thinking about how to introduce the concept here, I actually think I'm going to start at the end and work backwards so you can see the use case and then see why we had to develop them. So at the end of the day, what we were trying to do was better enable our boundary data. And by that, we have policy customers, desk officers at the department who are responsible for certain geographic units. So there's a China desk, and there's an officer there who may want to understand boundary issues associated with China. They're not boundary experts. They need a way to quickly access and understand relevant topics related to this boundary. So the Boundaries and Sovereignty Encyclopedia, or BASE, was our solution to this. So I'm going to go through this just quickly. I've got some tabs open already, but it's all interactive. So you can just click on this map. I mean, we have them. We have land boundaries and maritime, which is a whole other world. But let's just say we clicked on China. And what this page does is it assembles all of the relevant boundaries for China and presents it as one unified view, even though that isn't how we fundamentally manage land boundaries, and I'll get to that in a minute. But this is a web visualization tier, right? So, but you start to see here all of the individual components just in the land boundary side of what's necessary to create the cohesiveness of a China entity. And that's not to include all the other maritime boundaries and limits. So you can start to see that there's a lot of data here, and there's a lot of sub-segments. So if you're like, okay, I'm interested in understanding more about the India-China border specifically. So now we get actually into borderland, where borders are negotiated elements between two parties, so between China and India. But not all segments of a border are actually identical. We, as the United States government, we don't recognize everything as being at the same legal status. So there's actually subsegments, or there's areas that are in dispute by the parties involved. So just as an example, here all goes out 4 pages worth of individual segments that have to be cohesively stitched together to form an India-China boundary as you would think about it. And then that boundary has to then be part of an entity called China, right? So if we drill down one more, we can see actually one of these little segments here, which is one of the disputed areas. So, and then BASE, these lines are very important. They are like the physical manifestation of our foreign policy. It divides, this is the United States government's perspective on sovereignty in the world. But the lines aren't just enough. You have to show your work. And because boundaries are often treaty negotiated, there's maps, there's a huge amount of documents that go behind each one of these. And so what BASE is trying to do is be that repository of all the information that our analysts would use. And I guess I should scroll down here, like if you want to see how much we've written. So BASE contains all of this written analysis, links to maps, various issues, blah, 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 right? So the question is, with SpaceTime IDs, is first off, why do we need them? It's to enable that, right? And we also have a couple other authorities at the geospatial data level that also need to be explained. So a little bit about I know that's a little bit inverse, so I was hoping to show you the end so it makes more sense as we go along, like why we were doing it. But the Office of the Geographer has several missions. One, it maintains the large-scale international boundaries data set. Two, we serve as the chair of on the Board of Geographic Names, the Foreign Names Committee of the Board of Geographic Names. And then we have a whole bunch of analysts who are working on an interesting portfolio supporting policy customers across the human security, humanitarian, climate, and science portfolios at State Department. So it's a super interesting place. So like, why did we need BASE? I mean, boundaries are critical to foreign policy. They are actually dynamic, and they're dynamic for a few different reasons, which I'll explain more. They have source documents that need to be there to show your work, and policy customers are not boundary experts and need to quickly be able to access relevant information. So why did we need SpaceTime IDs? In more, wordy geospatial language, the hierarchical assembly of line segments into semantically meaningful units, right? We needed a way to link those because country names can change over time. And so a SpaceTime ID actually locks a configuration of a boundary into a single ID. That's its geometric layout, its spatialness, the two countries involved, the rank, the status, any notes that we have about it. Going forward with the management of this data set, any change is a change, which means anytime there's a change in any of those, the geometry, the geography, or the attributes, a new SpaceTime ID will be issued such that we can track that. So that's your current ID. We track things called previous IDs and antecedent IDs, which we'll get into the use cases for that in a minute. But then the harder part is these persistent links into BASE. So a document, a treaty, let's say from 100 years ago, that was negotiated by two parties who no longer exist on the face of the earth, might still be relevant to a modern boundary today. And I need an analyst to quickly be able to get in and have the system surface that piece of information to them as relevant, even if they don't know its history and lineage. And SpaceTime IDs and this tracking mechanism facilitate the maintenance of that relevance link to digital documents. So in the day and age of the Geospatial Data Act, State Department is the lead federal agency for international boundaries, which means we are the National Geospatial Data Asset, the NGDA theme lead for international boundaries. There is only one data set in that theme, the large-scale international boundaries. These lines are maintained by the Office of the Geographer on behalf of the entire US government. And in theory, all US government maps need to use these lines and cartography and names. And then, as I've said, not only are there lots of source documents, there's lots of interpreted documents that come about that, right? If a treaty is adjudicated in a court, right, that's additional stuff. And then oftentimes, boundaries would be like, okay, here's a boundary stone 1 and here's boundary stone 2, and connect between them following the ridge line. Well, the better we get elevation data, the better our ability to mathematically deduce or extract out that ridge line. And so even though the line hasn't changed legally, our ability to demarcate it on the ground has changed because data has increased. And so better satellite data, better terrain data. So we're just constantly in this refinement process. And that's outside of any geopolitical situations that might lead to a country emerging or going away. So we publish the large-scale international boundaries on a public website, geonode.state.gov. That's federated to data.gov and a geo platform. If you go there and download it, you'll get a zip file that has data. It has style files for QGIS, it's SLD, so for QGIS and GeoServer, and Esri language, styling language, as well as GIS application files with the data already loaded and the styling already loaded. So we're trying to take the guesswork out of it. You're free to modify it. There are rules in the metadata, in the human readable and the machine readable metadata, about cartographic guidance. But we try to, with these current releases, give you something to get running with right out of the box. And so you literally unzip, you go into that apps folder, there's a QGIS document, you open it, you see that it's styled. What the arrows are showing here is the fundamental element to keep in mind is the status of the line. A rank 1 is an adjudicated, that's like we believe that there's a legal authority for that boundary. And then there's two other ranks, 2s and 3s, where they're just, you have to read into the metadata specifics, but they're basically like lines that we recognize might be in dispute or other special lines. And so in this case, this is South Sudan. This is an area called Abyei. It's a special zone, so we demarcate that by a rank 3. And then here's a rank 2 on the Sudan-Kenya line a series of rank 2s. So wanted you guys to know about that because the cartography, in many cases people want flexibility. In this case, it's actually a policy statement, how it's styled. We have rebuilt and deployed a geo network. We're going to pivot off of GeoNode. Thank you. And so the URL for this is forthcoming. It's all commercial AWS with the data in S3 served out and in CloudFront, so it's fast everywhere. So just to touch more, I kind of spoke to this a little bit, but I'll go quickly. But it's important to remember that boundaries are bilateral agreements between two entities, and they're grounded in there's this legal document detritus that kind of emerges from the process. As I said, they change over time, either new agreements, better data, countries change. We call it the Yugoslavia problem, right? Lines are composed of smaller segments. Certain treaties might only depict a certain distance on the ground, right? And oftentimes, there are multiple competing claims for territory, which introduces a very strange wrinkle, which I won't be able to get into here, but we're working on a world polygon data set and the ability to bring polygons into lines as disputed in the encoding for disputed areas. So here's an example. So Finland went out and re-surveyed with differential GPS all of their boundary markers and republished an open report for their boundary markers. And so hopefully you can see this 10.2, previous version of the LSIB, those lines were digitized from Soviet General Staff maps. The Finnish government published out new guidelines and we ingested them as, it's not like the US government is doing all of the work here. We trust that, we're relying on the host countries to tell us and assert what their boundaries are. So you can zoom in a little bit and you start to see the change in detail. If we were to look at that in the current LSIB attributes, what you'll see is country 1, country 2, CC1, CC2. So you start to see our problem. If those entities change, you start to be able to, you can't link things over time. So what you see here is the ID and then the previous ID. So this is the new data in 11, and for 11.1, that's its new SpaceTime ID. So again, we're trying to solve two major problems, the hierarchical assembly of lines and the maintenance of relevance into digital documents. Really the kind of inspiration here kind of came from three places. I had previously done a bunch of work with GeoGig and then just working around a bunch of software developers and using Git some myself. And then an Oak Ridge project called WStamp also tried to tackle this idea of how entities change over time. And those three things together kind of led to this idea. A SpaceTime ID is nothing more than a UUID. It's just how we use it and the columns by which we track them. So let's do a hierarchical assembly question. So Ethiopia, Somalia is actually 3 segments, 2 rank 1s and a rank 2. So you can see here that while we're going to manage the rank 2 line as an individual segment, its ID will be different than the parent rank 1 line. And in the parent ID, we'll actually assign the parent of this line to the semantic concept of the rank 1. And so that's by looking at the parent IDs, you can stitch together those smaller ones. And we believe this model can actually work even farther down into smaller and smaller units. The atomic unit of boundary management would be the smallest things defined by treaties. We believe there's 12,000 of those segments. So what we're trying to do is drive down our management to that finest level, but still be able to assemble them back up. So in terms of doing all this work over the last 3 years, again, we're just trying to increase our own sophistication, scalability, and be able to disseminate more widely and in better used formats, leverage all the digital documents, and increase value to our customers. So I think I've kind of covered these already. If you're going to build a boundary archive, if you're going to build a base, what do you got to do? You got to manage changes in boundary alignment. You got to manage the fact that they're segments. You've got to manage the linkages, and you've got to provide the tooling, the web tooling, to make it easy to interact with and search and find the things you're looking for. So you've already seen some of this, so we'll move through this quickly. So if we jump back to Ethiopia, Somalia here, what you see is in the base written text, we describe these different segments. And base is running MySQL under the hood, and the geometries are stored in the database alongside the rest of the attributes and then rendered out into open layers for these map views. And I should thank our industry partners, Tesla Government. I forgot to do that at the beginning. This is their platform, State Today. So we work very closely with them as a team on the presentation and maintenance of this. State Today is also, base is also open to anybody with a .mil or .gov address. So the written analysis says, okay, here's segment 1, here's segment 2. Oh, here's a link to a map where we got that segment, right? And so you can go get the source yourself. So the way SpaceTime IDs, if we move out of hierarchical assembly and we get into search, I'm going to walk through an example that'll show where antecedent IDs, or how do you track IDs that disappear and maintain relevance. The base data model we think is expansive, but we haven't populated it enough with enough historical data to test all the corner cases. So the only one where we have an example of an entity that went away was from 2020, when President Trump at the time recognized Morocco's claim over Western Sahara, and overnight, US government policy said Western Sahara no longer exists. But base had about 500 digital documents tagged as Western Sahara. So there's the change between the two lines. Between 10 and 11, Western Sahara went away. So now if we go into base and we look at the current line for Morocco, what we see, and we're working on the UI of this, it's actually a little kludgy, but what we see here is an old segment that has an end date. And we know that, we also know that, I'm leading here a bit, but we also know that that segment has now been absorbed into the broader Algeria-Morocco line. So if we go to Algeria-Morocco, okay, wait, sorry. Okay, so if we access the original line that has now disappeared, we can view its metadata. We can see its ID at the time and when it ended, okay? So now, if we did a search for that in base, what you see is, here's a specific file about land boundaries. Just remember this particular file, peacekeepers.docx. So now if we go into Algeria, Morocco, we've encoded in base that, using the antecedent IDs, that the current line is actually derived from this line that's gone away. So the unique identifier, the base SpaceTime ID for the current line is this one. And we can see that it's got antecedents. So that previous line has now been stored in the antecedent ID column. So now if I come in and do a search, if I'm an analyst and I'm like, I need to understand what's going on with Algeria and Morocco, I don't even need to know that Western Sahara previously existed. The base search functions, the relevance of the document that was to Western Sahara is now relevant to Algeria and Morocco and shows up in the search results. So this is a way that you can get, the system can surface things that are important to you without you having to know the full history. So here's peacekeepers.docx in the search for Algeria, Morocco. We think this has potentially a lot of, if we build out historical situations, Azerbaijan, Armenia is one that kind of comes to mind. Right now, there's like a historical place where we might do a pilot. How much time I have left? Okay, 19, perfect. We also have explicit spatial search baked in. So every object that goes into base can have a geographic coordinate associated with it. And not just a point. It can have a complex geometry. You can have a WKT of whatever it is. So, and then there's spatial filtering so that you can surface things and discover things on the basis of pure proximity and not just relevance proximity using the base IDs. And so we also, in this case, we do have some spatial files that will be in there. So we had base 1.0, which was originally built in 2004, had gotten really long in the tooth and was really falling down tech-wise, but had this huge dark archive of information. And we literally did a lift and shift over into this new one. So it's still kind of messy. This is going to be a process. This is going to be a generational thing to go through and re-stitch all these things together. So with that, we are continuing to work on automating and refining our process for editing LSIB segments, stitching them into individual lines, stitching those into an LSIB release, and then we're actually working on being able to release US government sanctioned polygons for geospatial analysis in close time with an LSIB release, which is going to be a big thing. We're working on a paper to publish this, so I'm certainly open to any feedback. Would love to know, where this has fallen down, if any other approaches that might be relevant here. And our overall goal is to open base to the public, and there's really nothing stopping it. We've gone through and done the only concerns we have is making sure that we haven't accidentally violated copyright for having maps. And so as we get through the content scrub of everything, the goal is to make it open. But right now, it exists literally on the internet, statetoday.net/base. If you have a government or .gov.mil account, sign up for one, you'll be authorized immediately, and we would love any feedback that you have there. So thank you for coming, thank you for listening, and I look forward to talking more. So the question is, does the State Department monitor how boundaries are represented in commercial providers? The answer is yes, and part of the reason for getting to a repeatable release cycle for the world polygons and LSIBs, how it comes across our desk is we do a whole lot of smacking people on the knuckles for using bad maps, but there's not a viable solution that's out there. So I'm trying to get to a point where I can create a data output that we can go back to industry and say, hey, I can't solve your entire global tiling problem and sub-admin conflation problems. You've got data engineering workflows for that. But if I can give you the outer shells in a consistent data product, can you build me a USG sanctioned version? That's been a goal for many years for me. And so what we're trying to get to on this release cycle is being able to provide industry some assurance that they'd have something to build on. Yeah, Elliot.
Yes. Do you attempt to track Antarctic claims and then the forward projection issues of you have the map of Mercator? I was curious if you have Antarctic.
So the question is, do we have Antarctic stuff? We do. It's not exposed here. There are no international boundaries in Antarctica, so we don't track them here. Just like there's no international boundaries in Australia. If you download the data set, there's nothing for Australia because it's just a shoreline. But also these maps are in 4326 and they're in open layers. So I chose open layers so that if we got to a polar projection issue, we'd be able to support it. Yeah.
So I was just a little government and we have a web geospatial application. So I have two questions for you. At the beginning of your talk, you mentioned, so you have this great seamless that kind of shows the disputed boundaries versus the known boundaries very well. Is that provided as a feature service that we could just consume it that way?
So the question is, do we have a feature service like a reference implementation of these dynamically? The answer is kind of. The GeoNode now has a WFS that is exposed behind it. We're actually going to, in the next move to the new platform, we're actually going to lose that for a little bit. We intend to rebuild it, but we want to, GeoNode ossifies all of those things together in one code block, and we want to break those things into pieces. So the first goal is to get a metadata catalog that is bulletproof, and then we're going to stand up reference implementations. And much of this new modern, kind of Cholmes' talk yesterday on cloud native SDI has me thinking about flat files and getting out of servers altogether. So I think we're going to have some conversations about expressly how that's going to happen. So yes, no, maybe, kind of, there will be.
And my second question is, have we thought about scale very much? We do use the LSIB in our geospatial application, but the second we start zooming in, then our other data layers do not hear your...
Yeah. So this is a huge problem and what World Polygons is designed to fix. The question is, what about scale? So with World Polygons, the intent is to have perfect alignment between the internal boundaries of polygons and the LSIB. And we're producing them at 3 scales. Full resolution, which is, there's 4.1 million nodes in the LSIB and about 9 million when you put the shoreline in it. So it's a lot to draw. There'll be 2 levels of generalization, one for regional scale maps and one for a hyper generalized level for global maps or very lightweight stuff. And those will all be delivered to you in a seamless We will build the GIS applications with the cut points in the scales and give it all to you in a way that it just automatically zooms through and picks the one we think you should use at a certain scale.
Thank you so much.
Yeah.
Just out of curiosity, how far back does this data go? You're saying like, yeah, policies from 100 years ago, that far back.
So the question is, how far back does the archive go? I'm actually not sure what the oldest documents in there are. There's not geometries. Our next step is to pick a pilot area to do a deep dive and do a full historical reconstruction using this model. I think there's a lot of resources in BASE already that we could draw from. And that's why I say, like, we think this should work, but we haven't tested everything yet. So, but I'm happy to talk more after this, but we've got to switch everything out. Thanks again, everybody, for coming. Appreciate you.
Nice job.
Thanks, man.
Appreciate it.